Okay, in this part, let us study a few more examples. Okay. So this is an voltage source. This is 5 ohm, 10 ohm, and this is 10 volt. Six ohm, 4 ohm. Okay, 4 ohm. Okay, so in this question, ask you to find the current I1, I2, 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 and also I3, I3. Okay, so to find I1, I2, and I3. So in this question, we may use the mesh analysis. Mesh analysis, which means we use a KVL, Kirchhoff current law. Okay, so clearly we have two mesh. One mesh is like this, and another mesh is like this. So actually, this one should be I1 because we have a current here. So I1, I1, but this is not I1. But we'll see what it really is. And for this one, I2 is the current going in this path. So actually, this one should be I2. This one should be I2. And actually, I3 should be I1 is going downward. I2 is going upward for this path. So I3 should be I1 minus I2. Or if you use the KCL at this node, you can see that I1 is going inside, I2 and I3 are going outside from this node, which means that I1 should be equal to I2 plus I3. So if you move this term to the left hand side, you also get I1 equals I2 to, plus I3, which will be exactly the same equation. But here, when we use the node analysis, we can use another direction to do the same thing. So in this case, I1 is is clockwise, and I2 is also clockwise. So for this path, I1 is downward, and I2 is upward for this single branch. In this case, I1 minus I2 should be I3 going in this path. Okay, so let's write the mesh equation. So for mesh 1, which means this mesh, So 15 volt is so this is lower voltage and plus 15 volt. So this 15 should be positive and going this way. This 10 volt, this is higher, this is lower. So this is opposite to this current, to this mesh. So we should have minus 10 for this one and this one for mesh 1. Okay, so on the right hand side, let's consider the voltage drop due to the resistor. So in this mesh there are two resistors. This is 5 ohm, and the current should be I1. So we have I1, and this is the 10 ohm resistor. So we have a plus 10, and the voltage drop for this should be 10 multiplied by I1 minus I2. So we will write the mesh equation for mesh 1 like this. 15 minus 10 equals 5I1 plus 10 times parenthesis I1 minus I2. So for mesh 2, which means this mesh, so 10 should be a positive value because this is lower, this is higher, same direction with this mesh. So 10 should be positive in this mesh, and there are no other voltage source. So on the left hand side there's only 10, and for the right hand side 10, this 10 should be multiplied by I2. I2 is in this direction, and I1 should be in the opposite direction. So we have I2 minus I1 multiplied by this 10 is the voltage drop on this mesh. And for this one, 6 and 4, 6 ohm and 4 ohm. 6 ohm and 4 ohm. Okay, so the current going through these two resistors are all I2. So it looks like this. And actually, so we can do some simplification. We have 5I plus 10I, 15I1. And then minus 10I2. And for the second one, minus 10I1. And then this one, plus 10, plus 10. So we have plus 20I2. Okay, so let's see. So actually, maybe we can call this equation 1, equation 2. So for equation 1, we divide it by 5. So we have a 5I1 minus 2I2 equals 15 minus 10 is 5, divided by 5 is 1. And the second one, we may divide it by 10. So this one minus I1, this one 2I2. So 10 minus 10, 1. So when we add them together, so we have a 2I1 minus 2I2 plus 2I2 can be cancelled. And on the right hand side, 2. So I1 is 1A, I2 is 1 half 1 plus I1. So 1 half 1 plus 1, so also 1A. Yeah, 1A. So actually we have 1 I1 equals to 1A, I2 equals to 1A, and for I3 we know that I3 is actually here I1 minus I2. So I3 is I1 minus I2, which is 1 minus 1, which is 0A. 0A. Okay. So this is simple. And let's see. Well, so actually we can also just to verify the answer is correct. Just to verify the answer is correct. Okay, so we know that I1 is 1A, 1A. This is also 1A, and I3 is 0. I3 is 0. So this is ground. This is ground. Maybe I choose to use black color. So this is ground. So this is 0 volt. No doubt. So this is this one is 10 volt. So it should be 10 volt here, 10 volt here. And this one 0 volt, 0 volt plus 15. So this is 15 volt. And so this one is 1A, this one is 1A, and this one is 4 ohm, so there should be a 4 volt here, okay? And there is no current going through, which means I3 is 0, no current going through this resistor. So this is 10 volt, this is also 10 volt. So let's see, this is 15 volt, this is 10 volt, so this is 5 ohm, so the current should be 15 volt minus 10 volt, all divided by 5, so which is 1A, which means this is correct. And this one is 10 volt, this is 4 volt, 10 volt minus 4 volt, all divided by 6 ohm, so current is 1A, this one is also correct, so we can actually verify our result very easily. And how about if we can use the node analysis to do this question? The answer is yes. The answer is yes. Maybe we can quickly do this by the node analysis. So this is 5 ohm, this is 10 ohm, this is 10 volt, and this is 15 volts, and actually this 6 ohm and 4 ohm is in series, so I can simply write it as 10 ohm, something like this, which is actually the same. So in this case, we actually have one node. This is Vx, this is Vx, and this is 0, so this is 10 volt, this is 15 volt. So we can use the node analysis to write a node equation. So actually, I assume the current are going outside. So for the left one, we have Vx minus 15 over 5, and the bottom one, Vx minus 10 over 10. And then the third one, Vx over 10. Actually, Vx minus 0, but which is Vx, and then over 10 for this resistor. So equals to 0. And then we can just simply multiply 10 for both sides, on both sides. So we have 2Vx minus 30 plus Vx minus 10 plus Vx equals to 0. So we have 2Vx, Vx, Vx, totally 4Vx, and then we have minus 30, minus 10, so totally minus 40. And then we move it to the right hand side, so it is 40. And finally we get Vx equals to 10 volts, which is actually the same as here. So we can just calculate the current. So actually even the same problem, you can use the mesh analysis or the node analysis, and it depends. It depends on the circuit itself. You cannot tell whether node analysis or mesh analysis is better for general case. You can only tell it one by one, but case by case. But usually the two methods won't be a lot of different. But maybe for this case, a node analysis is easier because you only have one variable. But actually for this one, for the mesh analysis, you need to have two variable, which may be a little bit more difficult. But but I think both of them are quite simple. Okay, so let's go to the next example. Let's see, 80. Okay. So let's see another example with the supernode. Okay. So this is a 4 ohm resistor, 2 ohm, 10 volts, 8 ohm, 5 volts, 6 ohm. So actually we can use node analysis to solve this circuit. And so suppose we use the node analysis. We should know the node voltage. So actually there are several nodes. This node you shouldn't need to calculate because this is ground, so 0 volt at this node, and this is a 10-volt voltage source, so this node must be 10 volt. Okay, so for the next, there are still two nodes. One is here, one is here, or you can take that one. So it looks like there are two nodes, but actually between these two nodes there is actually an ideal current, ideal voltage source, which means that as long as this one is V or maybe Vx, then this one must be Vx plus 5. Vx plus 5. So actually we can regard this adjacent node as the supernode. This is the supernode. And we'll try to write the node equation according to this supernode. So well, so there are 1, 2, 3, 4 paths. 4 paths. So the first one, this one, Vx plus 5 minus 10 over 2. So this is the first current going outside, and then plus the second current, which is Vx plus 5 minus 0. So over 8. So this is the second one, and this is the third one. This node should be Vx over 6. So this is the third current going outside, and then the fourth one, this one going this way. So this is Vx, this is 10 volts, so this is Vx minus 10 volt over 4 ohm. So equals to 0. So add all the 4 current, and then equals to 0. So let's multiply both sides by 24. So for the first one, we have 12 Vx, and then here 5 minus 10 minus 5. So multiply by 12 is minus 60. Minus 60. For this one, multiply 24. So we have 3 Vx plus 15. And then next, we have this one. So we have 24 over 6 is 4. So we have plus 4 Vx plus 4 Vx. And for this one, 6 Vx plus 6 Vx minus 60 equals to 0. Okay, so we have 12 plus 3, 15, 19, 25. 25 Vx 60 plus minus 60 plus 15 minus 45 minus 60 minus 105 equals 0. So Vx should be 4 point something. 4 point something. Uh, Let me see. 5 over 25. 5 over 25 is 5 over 25 is 0.2, so 4.2 volt. Okay, so 4.2 volt. So so this one will be 4.2 volt, and this one will be 9.2 volts. So actually, after you know the no voltage, you can calculate whatever current you want in this circuit. And actually, if you want to know the current going through the voltage source, you must use the KCL here, so that you calculate the current going through this 2 ohm resistor, going through the X ohm resistor, so that the current going through this voltage source equals to this current plus this current. And if you want to know the current going through this resistor going upward, which will be this current going this way plus the current going to the right hand side, which will be the current going through the 10 volt voltage source. So, so far we cover some example. Known as the supernode, you may be curious about whether we have a super mesh. The answer is yes. The answer is yes. We have super mesh. So let's try an example about super mesh. And actually this example is quite easy. So we have 20 volts, 6 ohm. So this is 10 ohm. This is 4 ohm. This is 2 ohm. And this is 6A. 6A. Yeah. Yeah, something like this. So let's try to use the mesh analysis to solve this question. Actually, you can use node analysis, no problem, and it will give you the same answer. But let's try to use the mesh analysis. So first of all, we draw the mesh. So mesh 1 here, mesh 2 here. Okay. Actually, as you know, the mesh analysis uses the KVL, which means that the voltage drop go over a complete loop should be 0. So when the loop goes from here to here, the voltage may go up, and going here maybe may go down. Then it turns out for the whole loop, the voltage difference should be 0, because actually it's the same point, so there shouldn't be any voltage difference. So the overall voltage changes should be 0 over a complete loop. And for this one, you know that the voltage difference is 20 volt, no problem. And as long as you know the current, you will be able to know that the current, the voltage drop for this 6 ohm resistor is 6 times I1, no problem. And for this one, a little bit more complicated, but still no problem. It is 2 times I1 minus I2. But for that one, for the current source, as you know that the current of this current source is fixed, but you won't be able to know the voltage drop. You will not be able to know it. You cannot write an equation of the voltage drop here, So actually, what we could know is that I2. So actually, in this case, we have the super mesh, which means that I1 and I2 already have some relationship, and actually I2 minus I1 is 6a, because I2 is in this direction, going up for this branch, I1 going in this direction, so going down for this branch. So the current is 6a going upward, so it should be I2 minus I1. I2 minus I1. And in that case, we should consider the super mesh like this. Consider the super mesh like this. Actually, the outer loop is the super mesh. Then we consider the voltage changes over this loop rather than this one or this one. So in this case, so 20 volt is a voltage source, and over this loop there is only one voltage source, so only 20 on the left hand side, and on the right hand side we have this 6 ohm resistor, and the current is I1. And actually for this one you can write it as I2 equals I1 plus 6. Okay, so just move I1 to the right hand side. And then for this resistor, this is 10 ohm and the current is I2, so it is I1 plus 6. And for this 4 ohm, it is 4, and the current is also I2, so I1 plus 6, like this, plus. Okay, so we just do some simple algebra. So we have 10I1 plus 60 plus 4I1 plus 24. So we have 4, 6, 10. So 20I1. And then take 60, 24 plus 84. So 20I1 equals to minus 64. And thus I1 is minus 3.6 3.2 3.2a, and in this case I2 is actually I1 plus 6, so 2.8. So this is I1 and I2. I1 is minus 3.2a, and I2 is 2.8a. So we can simply verify it. Actually, so this is 2.8. So the voltage at this node should be 2.8 times 4, which is 4 times 8, 3.2, and then so it is 11.2 volt. Okay, so so this is 20, this is 6, this is 6. So and the current is I1 to be minus 3.2a. So this voltage, the voltage here should be higher than this one, because it's actually like 3.2 going to the left side, 3.2a going to the left side. So 6 times 3.2, 19.2 plus 20. So this node should be 39.2 volts. 39.2 volts, and you can verify this is 2.8a. So 39.2 minus 11.2, which is 28 over 10 ohm, is 2.88. So this matches. So in this case, we know that 6a is going upward. So at this node, the node voltage here should be 39.2 plus 2 times 6a. 2 times 6 is 12 plus 39.2, which is 51.2 volts. So we know that the voltage across this current source is actually 51.2 volts. So maybe we have a break here, and